Hello everyone, my name is S.K. Karthikeyan, Associate Professor, Kongunadu College of Engineering and Technology. Today we are going to see the gears and gear train from the Unit 4 of Kinematics of Machinery subject. You know very well, gears are used to transmit motion from one place to another place. And coming to the gear train, it is a combination of wheels by means of which motion is transmitted from one shaft to another shaft. So this is the application of a gear train. You have seen this kind of arrangement in a watch. So the watch having many number of parts, that is battery, motor, circuit board, microprocessor. Along with that, we have this kind of a gear train arrangement. Coming to the introduction for gear train and gear train value, speed ratio of gear train is nothing but the speed of the driving gear divided by driven gear. The train value is reciprocal of speed ratio, that is 1 by speed ratio, that is speed of the driven gear divided by speed of the driving gear. Normally the positive value of the train value indicates both the driver and driven rotate in same direction. If it is negative, means opposite direction. So this is the classification of gear train. Normally it divided into two main classification, that is ordinary gear train and epicyclic gear train. Ordinary gear train having simple gear train, compound gear train, that is furtherly divided into reverted gear train, non-reverted gear train. And coming to the epicyclic gear train, it is classified into simple epicyclic gear train, compound epicyclic gear train. So this is the arrangement of simple gear train. You have seen two gears that is measured externally and having the name 1 and 2. The first one receives the rotation from the motor, that's why we call it as driver. That driver gives the rotation to the next one. So the next one is named as driven or follower. So there are two names we are going to use frequently. One is driver, another one is driven. Here gear 1 is driver, gear 2 is driven, that is follower. Then coming to the speed of both the gears, that is notated by the letter N. So N1 is speed of the gear 1, N2 is speed of the gear 2. Similarly for number of teeth, T1 is the number of teeth on the gear 1, T2 is the number of teeth on the second gear. So coming to the gear speed ratio, N1 by N2 is T2 by T1, that is derived from the formula N1 T1 equal to N2 T2. So you know very well train value is the reciprocal of speed ratio, so 1 by speed ratio. So the formula become N2 by N1 equal to T1 by T2. And coming to the next one is intermediate gear train. Normally we mention it as idle gear train. So normally we are using idle gears for that is filling the space between the two gears. So normally depend on the application we are introducing number of gears, the gear size going to differ, number of teeth going to differ. Sometimes whenever we fill the gap, bridge the two gears, means we are going to introduce number of gears. Sometimes it also used for changing the direction of rotation. So this is the speed ratio for the gears. So you consider N1, N2, N3, N4 are the speeds of the gear 1, 2, 3, 4, and similarly for T1, T2, T3, T4 for number of teeth on the respective gears. So coming to speed ratio for gear 1 and 2, N1 by N2 is T2 by T1, that is driven from the formula N1 T1 equal to N2 T2. Similarly for the gears 2 and 3, N2 by N3 is T3 by T2, and for gears 3 and 4, N3 by N4 is T4 by T3. So you do the cross multiplication, you keep all the speeds in one side and number of teeth in the other side. Finally you got N1 by N4 is T4 by T1. That is speed of the driver by speed of the driven is equal to number of teeth on driven divided by number of teeth on driver. So coming to the train value, it is reciprocal. Speed of the driven by speed of the driver is nothing but speed of the teeth on driver divided by number of teeth on driven. Then the third one is compound gear train. Compound gear train. So when more than one gear on a shaft is called compound gear train. So the advantage is nothing but larger speed ratio can be obtained with the smaller gears. Different gears can be used in order to suit the given conditions. Motion can be transmitted in the round bends and corners. So this is the speed ratio and train value formulas. As usual, you consider N1, N2, N3 for the speed of the gears, and T1, T2, T3 up to T6 for number of teeth on the respective gears. So as usual, you do the combination gear 1 and 2 having the combination N1 by N2 is T2 by T1. Similarly for N3 by N4, T4 by T3, N5 by N6, T6 by T5. You keep all the speeds in one side, number of teeth in another side, do the cross multiplication, because here some speeds are same. N2 is equal to N3, N4 is equal to N5. So you do the cancellation work, and finally you achieve N1 by N6 is T2 by T1 into T4 by T3 into T6 by T5. That is nothing but speed ratio is speed of the first driver divided by speed of the last driven. That is also equal to product of number of teeth on the drivens divided by product of number of teeth on the drivers. The train value is the reciprocal of the speed ratio that we have seen already. Then coming to the reverted gear train. Reverted, that is the unique name, we use it here because when the axis of the first gear and the last gear, that is last driven, are coaxial, then the gear train is known as a reverted gear train. You see the gear 1 axis and the last gear, fourth gear axis, both are passing in the same axis, line. That's why this is known as a reverted gear train. So this is the speed ratio for calculation for a reverted gear train. Here we have to consider one condition, that is the radius of the first gear plus radius of the second gear. That is first combination is equal to second combination. That is R1 plus R2 is equal to the next set of combination R3 plus R4. Likewise you have to do the calculation. Here we have the formula for small r is m into t divided by 2. Here m is nothing but a model. Then similarly you do the calculation for R1, R2, R3, R4 and substitute in that formula. We finally get T1 plus T2 equal to T3 plus T4. So speed ratio is product of number of teeth on drivens divided by product of number of teeth on drivers. And finally, when you keep all the n value, t value in left right sides, we get the answer as n1 by n4 equal to t2 into t4 divided by t1 into t3. So the applications of the reverted gear train is mostly used in automobile gearboxes, lathe back gears, industrial speed reducers, clocks. And coming to the last topic, epicyclic gear train. This is the topic that we are going to see with some examples. A gear train that consists of one or more outer gear rotating around a central gear. That is look like a sun and planet arrangement. The planets are rotated around the sun. Is the example for this epicyclic gear train. The applications are, these are all mainly used in the differential gears of automobile, back gear of a lathe, pulley blocks, hoist, wrist watches. The types are simple epicyclic and compound epicyclic. And the simple epicyclic, when one gear having external mesh with the other gear by locking up a pin, that is or arm, is known as a simple epicyclic gear train. And coming to the compound epicyclic, this is the compound arrangement when there are more than one gear in a shaft of a arrangement. We mention it as compound epicyclic gear train. So there are two methods in finding of velocity ratio. One is tabulation method, another one is algebraic method.